Could it be that the universe we live in is only one among countless others? The thought is unsettling, as if the night sky were just a thin veil, hiding endless parallel worlds we were never meant to touch. Science has left us with a few clues. From the faint glow of the cosmic microwave background mapped by Planck to the models of cosmic inflation, all point to the possibility that space may have given birth to many bubbles. Each bubble is a universe of its own, perhaps with laws of physics entirely different from ours. And then, the mystery opens wider. If those universes truly exist, then somewhere, another version of you may be listening to this very story beneath a sky not our own. Tonight, we begin a quiet journey to ask, just how many universes are drifting alongside ours? Part 1. The first shiver. Are we living in just one bubble? What if I told you that everything you know, the stars above, the ground beneath, the very laws of physics that let your heart keep beating may not be unique? That our universe, stretching 93 billion light-years across, may be nothing more than a bubble, drifting quietly in an infinite ocean of other bubbles? The thought is chilling. It makes the night sky feel less like a ceiling and more like a fragile window, hiding realities we cannot see. Pause for a moment and let that possibility settle in your mind. We are used to imagining the universe as the totality of everything, the final container, the absolute whole. But what if it isn't? What if our universe is just one chapter in a book with infinite pages? And stranger still, what if there are other versions of you, reading this same line, under a sky that is almost, but not quite, the same? This is where science and imagination begin to merge. In 1980, a young physicist named Alan Guth proposed the idea of cosmic inflation. According to his model, in the first trillionth of a second after the Big Bang, the universe expanded faster than the speed of light. That sudden stretching smoothed out the cosmos, explaining why the sky looks so uniform when we map it. Years later, the Planck satellite, operated by the European Space Agency, captured the faint afterglow of the Big Bang, the cosmic microwave background radiation. Within that afterglow were tiny fluctuations, patterns that matched exactly what inflation had predicted. It was a triumph of theory meeting observation. But inflation comes with a strange consequence. If space can inflate once, it can inflate again, and again, and again, and again. Like soap bubbles forming in a sink, each region of inflation could give birth to a new bubble of space and time. Each bubble becomes a universe. Each expands, evolves, and writes its own story. By this logic, our universe is not the universe. It is just one bubble in a cosmic foam, one verse in a multiverse. And here is where the ground grows less steady. If the multiverse is real, then each bubble could have its own rules. In one, gravity might be weaker, so stars never form, and eternal darkness reigns. In another, the speed of light might be slower, creating a cosmos that ages at a different rhythm. Some universes might collapse instantly, never forming galaxies. Others might burn with possibilities unimaginable. And somewhere hauntingly close in the landscape of infinity, there may exist a universe almost identical to ours. A universe where another version of you exists, living a life only a fraction different from this one. The question that chills scientists is not just if such universes exist, but how many. Is it dozens? Billions? Or infinity itself, stretching beyond all comprehension? The mathematics of string theory even suggests a staggering number: 10 circumflex 500 possible universes. That's a 1 followed by 500 zeros more universes than atoms in the observable cosmos. Numbers that big stop being numbers. They become poetry written in mathematics. And yet, for all its strangeness, the evidence keeps whispering. There is the mysterious cold spot in the cosmic microwave background, a patch of sky, billions of light-years wide, colder than it should be. Some cosmologists have suggested it could be a scar, the aftermath of a collision between our universe and another. Others insist it is a mere statistical fluke. But the possibility lingers. What if our bubble has brushed against another? What if universes can collide, like drifting spheres that leave ripples in one another's skin? The unsettling part is how close we already are to the limits of knowledge. Our observable universe is 93 billion light-years across the maximum sphere from which light has had time to reach us since the Big Bang. But beyond that, space almost certainly continues. We cannot see it. We may never see it. And yet, logic demands that it is there. What lies beyond that horizon? More galaxies? More bubbles? More laws of physics? Or the edge of reality itself? Scientists call this the cosmic horizon, but the name does not capture its weight. It is not just a horizon, it is a prison of light. Beyond it, we can never look. Our entire universe is wrapped in silence, unable to see its neighbors, if they exist. And still, the numbers tease us. Inflation, quantum mechanics, string theory all whisper the same thing. Our universe is not alone. Imagine if every choice you have ever made split reality. In one world, you turned left. In another, you turned right. In another, you never existed at all. This is the strange suggestion of the quantum many-worlds interpretation. Every quantum event, every possibility, is realized in some branch of the multiverse. An infinity of you, scattered across infinities of universes, each living out a different story. If true, then, you are both unique and not unique at all. The deeper we go, the more fragile reality feels. What we call the universe may not be the whole, but a chapter. And what we call truth may only be one verse in an endless song. If this quiet journey has brought you even a small moment of rest, a gentle like or a soft tap on subscribe is much more than a click. It is a kind encouragement that helps me keep creating these starry travels. And if you'd like to leave a note, I would be truly grateful to know where you are listening from, and even more, to hear your thoughts, impressions, or suggestions. Your feedback helps me refine these voyages so they can grow more meaningful, and every word you share, no matter how simple, feels like a small star lighting the way forward. Now, as we drift onward, a new question rises from the dark. If universes exist beyond ours, do they ever meet? Could they collide? And if so, what would happen when worlds of physics crash together? And with that, we step toward the next mystery. Part 2. Colliding universes, when bubbles touch. What if the universe you see above your head tonight, every star, every galaxy, every thread of cosmic light, is not untouched? What if it carries a scar, a silent bruise in the fabric of reality, left behind when our universe brushed against another? The idea sounds like something from a dream, or perhaps a nightmare. Universes are meant to be self-contained, sealed bubbles of space-time drifting alone. But what if they are not? What if universes can collide? For decades, physicists have wrestled with this haunting thought. The theory of eternal inflation suggests that after the Big Bang, inflation did not stop everywhere. Instead, it continued in different regions, forever, creating an endless froth of universes, each one a bubble in a sea of infinity. These bubbles expand, stretch, and drift apart. But here lies the key. Bubbles in a sea do not remain separate forever. They touch, they merge, and when they do, the collision ripples through reality itself. If such a thing ever happened to our universe, what would it leave behind? We may already have an answer. High above us, in the faint glow of the cosmic microwave background radiation, lies a mystery. In 2004, astronomers studying data from the WMAP satellite noticed a strange region, a patch of sky, unusually cold, vast in scale, stretching nearly 1.8 billion light-years across. When the Planck satellite later mapped the sky with greater precision in 2013, the anomaly remained. This cold spot, as it is now called, does not fit neatly into our models of cosmic structure. It should not be there. One explanation is that it is simply a supervoid, an enormous region of space with fewer galaxies, leading to cooler microwave radiation. But the cold spot is too large, too pronounced, to be explained so easily. Some physicists have dared to whisper a bolder theory. It may be the fingerprint of a cosmic collision, a place where our universe once brushed against another bubble during inflation, the scar of another reality etched into our sky. Imagine it. Two universes, each expanding at unimaginable speed, drifting close enough to touch. Where they meet, energy bleeds, space-time warps, and a cosmic bruise remains. From our vantage point, billions of years later, it looks like a slightly cooler patch of sky, faint and quiet, yet possibly the most extraordinary evidence of other universes we could ever hope to see. But collisions between universes are not gentle affairs. The mathematics of quantum field theory paints a chilling possibility. If our universe exists in a false vacuum, a temporary state of energy, then a collision with a bubble of lower energy could trigger a chain reaction. That bubble would expand at nearly the speed of light, rewriting the laws of physics in its wake, annihilating everything we know before we even had time to notice. It is called vacuum decay, and if it ever happens, we will not see it coming. One instant, you are listening to this story. The next, space-time itself has been replaced. It sounds apocalyptic. And yet, scientists reassure us, if it is possible at all, it is likely far in the distant future beyond scales of time we can even comprehend. Still, the fear lingers, because eternal inflation makes collisions not only possible, but inevitable. With infinite bubbles forming, it would be stranger if they never collided. Somewhere, in the vast infinity, universes are crashing into one another right now, their skies shattering, their laws of physics unraveling. We may never see those collisions directly, but maybe, just maybe, our own universe has already been touched. The cold spot is not the only clue. Some cosmologists have suggested that if universes collide, they might leave circular patterns in the cosmic microwave background, concentric rings of unusual temperature, like ripples frozen in the afterglow of creation. Teams of scientists have searched for these signatures. So far, results are uncertain. Some claim to see hints, others find nothing. But the idea refuses to die because it is testable. If one day we map enough of the sky with enough precision, we may finally know. Others suggest looking not at light, but at gravitational waves. When universes collide, they should send out tremors in the fabric of space-time itself. Unlike light, which can be scattered and absorbed, gravitational waves pass through everything. They carry the raw story of cosmic events. Instruments like LIGO and Virgo have already detected waves from colliding black holes and neutron stars. In the future, space-based observatories like LISA could one day search for whispers from the very birth of universes. If such a signal were ever found, it would be a direct echo from beyond our bubble. But here is where the imagination drifts further. If universes can collide, could they also merge? Could two realities bleed into one another, sharing pieces of their physics, their histories? What if strange anomalies in our universe, unexplained constants, unexpected structures are not errors, but the leftovers of another universe stitched into ours long ago? What if, without knowing it, we are already living in a hybrid cosmos, part of a larger quilt woven from collisions across eternity? The thought is dizzying, almost too large to hold, and yet it grips us because it asks a question we cannot let go. Are we alone, even as a universe? Or are we already part of a community of universes, colliding, merging, drifting apart across a sea without end? And if this is true, then the night sky is no longer just ours. Every patch of darkness, every fluctuation in the microwave glow could be a message, a scar left by another universe, brushing against our own. The cold spot may be nothing, or it may be everything. As we drift to the end of this chapter, let the thought rest with you. If universes can collide, then reality itself is not fixed. It is vulnerable, it is fluid, and it is far stranger than we dare to believe. But the journey does not end here, for if universes can touch from the outside, another question rises, stranger still. What if universes can overlap, not by colliding, but by existing in the same space layered invisibly upon one another? Could another reality be unfolding right here, right now, beside us, unseen? That is where we will go next. Part 3. Overlapping realities, universes within universes. What if, right now, another universe is unfolding in the very same room you are sitting in? Imagine a version of this moment playing out beside you, invisible, intangible, another you, perhaps leaning in closer, perhaps already drifting into sleep, hearing these words differently. The unsettling idea is this: universes may not just drift apart like bubbles in space. Some theories suggest they overlap, layered on top of one another, like sheets of glass stacked so close that you can never tell them apart. What if reality is not singular, but crowded with possibilities? This is the domain of the many worlds interpretation of quantum mechanics, first proposed in 1957 by physicist Hugh Everett III. At its heart lies one of the strangest puzzles in science. The world of the very small, the quantum realm, does not behave the way our ordinary lives suggest it should. Atoms and particles seem to exist in many states at once, a superposition until we measure them. A photon can pass through two slits simultaneously, interfering with itself in the double-slit experiment, creating patterns of light and shadow that no single particle should be able to produce. For decades, scientists explained this paradox by saying that measurement collapses the wave function. In other words, reality chooses one outcome, and the other possibilities vanish. But Everett asked a more unsettling question. What if the wave function never collapses? What if, instead, all outcomes happen each one in a different branch of the universe? If that is true, then every quantum event is a fork in the road. Every choice, every random coin flip, every photon bouncing off your skin creates new versions of the universe. One where you turned left, one where you turned right, one where you survived an accident, one where you didn't, one where you are listening to these words, and one where you never found them. It sounds like science fiction, but the mathematics is startlingly consistent. Quantum mechanics works whether or not you assume collapse. And in fact, many worlds solves a thorny problem. It removes the need for a mysterious observer to force reality into a single outcome. The universe simply keeps branching endlessly into overlapping realities. But here's the chilling part. If these universes all exist, they are not far away. They are here, right here, occupying the same space, the same time, layered invisibly over our own. The only reason we don't notice is that quantum decoherence, the spreading of quantum states into the environment, keeps the branches from interfering with one another. It is as if each reality becomes sealed, unable to leak into its neighbors. Yet still, they are there. Imagine that. Every decision you've made has created a chorus of other yous, all drifting alongside you, unseen. Some are almost identical, separated by a single breath. Others are wildly different, because a small change in the past blossomed into a radically different present. The universe is not a line. It is a tree, branching every instant, growing into a forest of overlapping realities. And this raises haunting questions. If all realities exist, are they equally real? Are the other yous as alive, as conscious, as you are right now? Do their choices matter? Or are they shadows, playing out inevitably beyond your awareness? Philosophers have debated whether this interpretation makes free will an illusion, because if every possible choice is realized in some universe, then in what sense do we choose at all? Scientists, too, struggle with the implications. Many worlds is mathematically elegant, but testing it is almost impossible. The branches do not communicate. They remain invisible, forever sealed. And yet, there are whispers of possible cracks. Some researchers have wondered if rare anomalies, unexplained correlations, improbable coincidences might be subtle interference from nearby universes brushing against ours. These ideas remain speculative, even fringe, but the very fact that serious physicists consider them shows how unsettling the landscape has become. The longer you sit with it, the more dizzying it feels. You are not simply one person in one universe. You may be one of countless versions of yourself, each living out different outcomes of your life. Somewhere, another you is making different choices, speaking different words, perhaps even wondering about you. Somewhere, perhaps, another you is asking the same question: am I the only me? This perspective changes how we see everything. Every moment is not singular, but a node in an expanding web of realities. The cosmos is not only vast outwardly, billions of galaxies across 93 billion light-years, but vast inwardly, branching infinitely within itself. The multiverse is not just out there. It may be right here, hiding in plain sight, overlapping with our every breath. But what if, the boundaries between these overlapping universes are not absolute. What if, under rare conditions, they can bleed into each other? Could this explain mysteries we cannot solve? Déjà vu, sudden insights, uncanny coincidences? Are these the faint echoes of neighboring realities brushing against our own? Science does not yet have the tools to test this, but the question lingers like a shadow. And if this is true, then the story of the universe is even stranger than we imagined. We are not solitary beings in a single unfolding reality. We are strands in an infinite tapestry, each thread running alongside countless others, unseen but ever present. As you drift with this thought, let it soften into something quiet. If another you exists, in another version of this moment, then you are never truly alone. You are part of a vast branching of life and possibility, layered silently across the cosmos. But the mystery is far from over, for if universes can overlap here and now, layered invisibly in the same space, then another question rises. Could universes be created not by chance, but by design? Could intelligence itself, perhaps far beyond us, shape the birth of universes like seeds planted across the void? That is where our next journey will take us. Part 4. Designed universes, seeds of creation. What if the universe you live in was not an accident? What if the stars above, the laws of physics, even the fact that atoms can hold together to make your body, were not the product of blind chance, but the result of design? The idea is unsettling. It makes the universe feel less like a wilderness and more like a garden. But who planted it? And why? Scientists call this the fine-tuning problem. Our universe seems perfectly balanced for life. The numbers are almost too precise, as though set with delicate care. Take the cosmological constant, the number that determines the expansion rate of the universe. Its value is about 10 circumflex, negative 122 inches. Planck units unimaginably small, yet not zero. If it were just a little larger, the universe would have expanded too fast, and galaxies would never have formed. If it were smaller, gravity would have crushed the cosmos back into itself long ago. Out of all possible values, we seem to live in the one narrow band that allows stars, planets, and life to exist. It does not stop there. The strength of gravity, the charge of the electron, the ratio of protons to neutrons, all fall into the narrow ranges that make chemistry possible. If gravity were just a little stronger, stars would burn out in millions instead of billions of years. If the electromagnetic force were slightly different, atoms could not hold together. If the strong nuclear force were weaker by even 2%, the universe would be left with nothing but hydrogen, no heavier elements, no carbon, no life. Change the laws by a fraction, and the entire story of existence unravels. How do we explain this? One answer is the anthropic principle. We observe the universe to be fine-tuned because only in such a universe could observers like us exist. Out of countless universes, we simply find ourselves in one that works. It's like standing on a planet and marveling at how perfectly your feet fit the ground, forgetting that in all the places where they didn't fit, you wouldn't be standing there at all. But others see something deeper. Could fine-tuning be evidence of design? Theoretical physicist Lee Smolin once proposed the idea of cosmological natural selection, that universes may reproduce through black holes, with slightly altered laws of physics each time. In this view, universes are like seeds, and black holes are the wombs that birth new ones. Over time, universes that are good at making black holes become more common. It is a kind of cosmic evolution, with physics itself as the trait that mutates and spreads. Still, the analogy to life is striking. If universes can reproduce, who is to say they cannot also be designed? Some philosophers suggest that advanced civilizations might one day create new universes in laboratories, tiny bubbles of space-time that inflate into full-grown cosmos, each with its own laws. If intelligence can do this in the future, what stops us from asking, has it already happened in the past? Is our universe itself an artificial seed, planted long ago by a mind beyond comprehension? The idea might sound fantastical, but it aligns with questions in modern physics. We already simulate smaller worlds inside our computers, running models of galaxies, climate, even virtual realities. If we can do it in limited ways, perhaps others can do it in ultimate ways. The simulation hypothesis, famously argued by philosopher Nick Bostrom, takes this further. If advanced civilizations can create simulated realities indistinguishable from the real one, then statistically, we are more likely to be living in a simulation than in the base reality. If true, then our universe is not just designed, it is programmed. Every star, every law of nature, every thought in your mind may be part of an intricate design coded by intelligence far beyond us. But here is the deeper mystery. Even if our universe is designed, by whom? And for what purpose? Are we experiments in a cosmic laboratory? Are we stories written for amusement? Or are we, ourselves, the seedlings of a greater chain destined, one day, to create universes of our own? Imagine if humanity endures long enough to master energy and matter at cosmic scales. With technologies we can scarcely imagine today harnessing the power of black holes. Controlling quantum fields, we might one day design our own universes. We might choose the constants of physics like gardeners choosing seeds, planting new realities in the soil of infinity. And perhaps this cycle has already been happening for eons. Universes giving birth to universes, some by chance, some by design. The thought is both terrifying and comforting. Terrifying because it suggests we may be constructs, our world built for reasons we cannot know. Comforting because it means the cosmos itself is alive with intention, not empty chaos. Somewhere, perhaps, beyond the horizon of our bubble, lie the architects or the ancestors who planted the seed of our reality. And yet, another question lingers. If our universe is designed, can we find its signature? Are there flaws in the code, patterns in the constants, messages hidden in the microwave background? Some researchers have speculated that anomalies like the cold spot might even be intentional markers, fingerprints left behind by the architects. We cannot prove it, not yet. But the more we look, the more we wonder, is reality itself whispering to us that it is not an accident? As you drift with these thoughts, imagine the universe not as a wilderness, but as a garden planted long ago, perhaps, tended by unseen hands, perhaps left to grow wild, and within it, you, a conscious being, able to look up, to wonder, to ask why. That ability alone feels like evidence that we are part of something larger than chance. But if universes can be designed, another possibility rises. Stranger still, what if our universe is not only created, but watched? If design is possible, then so is observation. Could there be minds beyond our bubble, watching the story unfold, waiting for us to notice? That is the mystery we will face next. Part 5. The Watchers Beyond. Are we being observed? What if every star you see tonight is not just a distant sun, but also a mirror? What if the vast universe is not only a stage on which existence plays out, but an experiment being observed? The unsettling possibility is this: if our universe is designed, as we considered before, then perhaps it is also monitored. Perhaps there are watchers beyond the veil of space and time, studying us quietly, their gaze hidden in the very structure of reality. This is not just the language of myth. In physics, there is something deeply disturbing called the observer effect. In quantum mechanics, particles behave differently when they are measured. In the famous double-slit experiment, a photon can pass through two slits at once, creating an interference pattern unless it is observed. When measured, the photon chooses one path, collapsing into a definite state. In other words, the act of observation changes reality. Why should the universe care whether we are watching? And if observation is so fundamental, could it be that the universe itself is being observed on a larger scale? Some philosophers and scientists have stretched this further into the simulation hypothesis. If our universe is a designed construct, it may be similar to a simulation, a vast program running on incomprehensible machinery. If so, then perhaps there are observers, the programmers, watching the story unfold. We would be like characters in a grand cosmic experiment, unaware of the laboratory that holds us. But science, too, has hinted at strange anomalies that make us wonder. In 2008, Data from the WMAP satellite revealed a mysterious phenomenon called the dark flow, a massive movement of galaxy clusters, all streaming in the same direction, as if pulled by something beyond the observable universe. Later, the Planck satellite confirmed unusual temperature fluctuations in the cosmic microwave background, including the infamous cold spot. These could be random, but some physicists suggest they may be the fingerprints of other universes, or even signs of structure imposed from outside, like a frame around a painting, invisible until you look closely. And then there are the neutrinos, these ghostly particles, born in the hearts of stars and supernovae, pass through your body by the trillions every second. They barely interact with matter, moving silently through planets, through galaxies, through everything. Some researchers have speculated that neutrinos may hold keys to hidden layers of reality, a channel by which unknown intelligences could, in theory, observe us without disturbing our world. It is speculation, yes, but one that adds to the sense that our universe is not as private as it feels. The deeper question is not only whether we are observed, but why. If there are watchers beyond, what are they looking for? Are we an experiment, meant to see how life emerges from dust and chaos? Are we entertainment, like a story unfolding on an unimaginable screen? Or are we seedlings, being monitored as we grow, waiting to see if we will reach maturity as a civilization? And stranger still, do they ever intervene? Most scientists dismiss such thoughts as beyond proof. Yet, throughout history, humans have felt watched by gods, by spirits, by the stars themselves. Today, we phrase it differently, in the language of physics and cosmology, but the intuition is the same. We are not alone, not even within our own universe. Imagine, for a moment, that every constant of nature is not only tuned but also tracked, that every ripple in the cosmic microwave background, every pulse of a quasar, every flicker of starlight is part of a cosmic record, a database written into space-time. If so, then the watchers would not need telescopes. They would see everything, always, every thought, every action, every spark of consciousness. This brings us back to quantum mechanics. If observation collapses wave functions, then who, or what, collapsed the first one? Who observed the universe into being? Some physicists, like John Wheeler, have speculated that the universe is a participatory reality where observation itself, by conscious beings, brings the cosmos into existence. But what if we are not the first observers? What if the universe was already being observed long before us, by entities we cannot imagine? And here the mystery opens wider. If we are being observed, is it from beyond the universe, or from within? Perhaps the watchers are not outside but hidden among us, woven into the fabric of dark matter and dark energy that make up 95% of the cosmos. We cannot see them, but their presence shapes everything. The galaxies spin faster than they should. The universe expands faster than it should. Could these unseen forces be both physics and presence? The thought is dizzying. You are lying beneath the stars, listening to this story, and perhaps, just perhaps, something is listening to you. Not with ears or eyes, but with the subtle machinery of reality itself. The more we measure, the more we realize. The universe notices us, and maybe it always has. But here lies the haunting question. If we are being watched, what happens when the watchers reveal themselves? Would it be the end of our story, or the beginning of a new one? And if we are not alone, if our universe is an observed experiment, then the next question is inevitable. Are there signs, hidden in the structure of the cosmos, that tell us we are not the first, that others have walked this path before us? That is where our journey will take us next. Part 6. Echoes of Ancient Civilizations. Have others walked before us? What if humanity is not the first traveler through this cosmic wilderness? What if the night sky hides not only the light of stars, but the faint echoes of civilizations long gone? Imagine for a moment that others came before us, ancient beings who looked out at the same galaxies, wondered at the same mysteries, and perhaps left their mark on the universe itself. The question is not simply whether life exists elsewhere now. The deeper, more haunting question is, has it existed before? And if so, where are the traces? The silence of the stars is deafening. This is the heart of the Fermi paradox, named after physicist Enrico Fermi, who in 1950 famously asked, "If life is common in the universe, then where is everybody?" Our Milky Way alone contains about 400 billion stars, and estimates suggest at least 100 billion planets. With numbers that vast, it seems almost inevitable that intelligent life should have arisen many times. And yet, as we listen with giant radio telescopes, scan the skies with SETI, and now even probe distant atmospheres with the James Webb Space Telescope, we hear nothing. Or do we? In 1977, a strong narrowband radio signal was detected by Ohio State University's Big Ear radio telescope. It lasted 72 seconds. Astronomer Jerry Eman circled it on the data printout and wrote a single word, "Wow." The signal never repeated, and no source was ever found. Was it a transmission from an ancient civilization, or just a fluke of cosmic noise? Decades later, it remains unexplained. And then there are the fast radio bursts, FRBs. First discovered in 2007, these are millisecond pulses of radio waves coming from distant galaxies. Some repeat, some don't. Most are now thought to be natural, perhaps from magnetars, highly magnetized neutron stars. But their brightness, their energy, is staggering. A single burst can release as much energy as the sun emits in days. Could some of them, perhaps just a fraction, be the relic transmissions of civilizations long gone? Scientists cannot rule it out entirely. Cosmologist Nikolai Kardashev once proposed a scale to measure civilizations by their energy use. A Type 1 civilization harnesses all the energy of its planet. A Type 2 uses the full power of its star, perhaps by building a Dyson sphere, a shell of satellites that captures stellar light. A Type 3 controls the energy of its galaxy. Humanity, for context, is not even at Type 1 yet. But what if others reached Type 2 or Type 3 billions of years ago? Would their work still be visible? Some astronomers search for unusual dips in starlight that might betray Dyson spheres. Others look for waste heat, the inevitable byproduct of massive energy use, glowing in the infrared. So far, no confirmed megastructures have been found, and yet the search continues. But here is where the mystery deepens. If civilizations had billions of years to grow, perhaps they outpaced even our imagination. Perhaps they are no longer bound to planets, stars, or even galaxies. They may have migrated into the deep architecture of the universe itself, embedding their knowledge into black holes, dark matter, or even the vacuum of space. In this view, the silence is not absence. It is camouflage. We do not see them because they have merged with the fabric of reality. What if the cosmic microwave background, that faint afterglow of the Big Bang, carries encoded messages? Some scientists have idly wondered whether subtle anomalies in its pattern could be artificial, a kind of cosmic graffiti left by ancient beings who wanted future intelligences to know they existed. To us, it looks like noise, but perhaps, to someone with the right decoding, it sings. And then there is the possibility of archaeology beyond Earth. For centuries, humans have gazed at ancient monuments, the pyramids, Stonehenge, Nazca lines, and wondered whether they carried knowledge from the stars. Mainstream archaeology explains them as human achievements. But the urge to connect them to something greater reveals a deeper intuition that perhaps the story of intelligence in the universe is older, broader, and stranger than our own. Even in science, this intuition lingers. Astronomers searching the skies have occasionally found anomalous light curves, stars dimming in irregular ways. In 2015, one such star, KIC 8462852, better known as Tabby's star, baffled scientists. Its light dipped by up to 20% without clear explanation. Dust clouds? Comets? Or something else? For a moment, headlines whispered of Dyson spheres. Natural explanations remain most likely, but the mystery endures. The silence of the universe may not be silence at all. It may be that we are simply too young, too primitive, to recognize the echoes. Just as a child cannot read ancient inscriptions, we may be surrounded by relics we do not yet understand. Now let your imagination drift. Picture an ancient civilization, billions of years old. Its technology so advanced it has folded itself into space-time. Perhaps it has left behind signals we mistake for natural phenomena, the hum of pulsars, the flicker of quasars, the whisper of gravitational waves. Perhaps every cosmic mystery we struggle with is not only physics, but archaeology, the remnants of minds older than stars. And if that is true, then the question shifts. We no longer ask, where is everybody? We ask, what have they left behind, and how can we learn to see it? As you let this thought rest, remember, we, too, are leaving echoes. Our radio signals, our spacecraft, our data etched onto golden records are already drifting into the stars. Perhaps, one day, another civilization will stumble upon them and wonder about us, just as we wonder now. But the mystery is not finished. For if ancient civilizations have walked before us, if their voices still echo faintly in the cosmos, then another question rises like a shadow. Could those civilizations still exist, not dead, not gone, but alive in forms we cannot comprehend, immortal across universes? That is where we will go next. Part 7. Immortal civilizations, living across universes. What if death is not the end? Not for us, not for civilizations, not even for universes. Imagine a species so advanced, so far beyond us, that it no longer fears the passage of time. Imagine a people who have mastered physics so deeply that they live across trillions of years, through the death of stars, the collapse of galaxies, even the death of their own universe. Immortality may sound like fantasy to us, bound as we are to fragile bodies and fleeting lifespans, but on the cosmic stage, could immortality be possible? And if so, might there already exist civilizations who have conquered time itself? From the moment we are born, entropy stalks us. Stars burn out, galaxies drift apart, and even the universe itself is headed toward what physicists call heat death, a distant future where everything is cooled, energy is spread thin, and nothing more can happen. It is a bleak horizon, hundreds of trillions of years away. But some theorists ask, must it be inevitable? Or can intelligence find ways to endure, to outwit the decay of the cosmos? One path to immortality is technological transcendence. Already, we whisper about transferring human minds into machines, about creating digital consciousness. A truly advanced civilization, given millions or billions of years, could refine this to perfection. They could upload their minds into networks vast enough to outlast stars, resilient enough to survive cosmic catastrophes. In this form, they would no longer be bound by biology. They would not need planets or bodies. They would become patterns of information, woven into the fabric of space-time. Another path is stellar engineering. We have imagined Dyson spheres, colossal structures built around stars to capture every drop of their energy. A civilization capable of building such things could stretch the lifetime of stars, recycling matter and energy for billions of additional years. Some theorists even suggest they could ignite dead stars, giving birth to new suns, ensuring their survival through cosmic ages. And then there is the multiverse itself. If universes are countless, as inflation suggests, then perhaps immortality lies not in prolonging one cosmos, but in moving to another. Imagine a civilization that has learned to step from bubble to bubble, escaping the death of one universe by migrating to the birth of another. To them, universes would be like seasons, each one finite, but the cycle endless. They would be wanderers across reality, forever alive. The strangest possibility is that immortality may already be encoded in the laws of physics. Information, according to many physicists, cannot be destroyed. Even when matter falls into a black hole, its information may not vanish, but remain smeared on the event horizon, preserved in some hidden form. If that is true, then the minds of an ancient civilization could survive as information itself, immortal not as beings, but as patterns etched into space-time. What would such an existence feel like? Would they still think, still dream? Or would they become something altogether different, something we could not recognize as life at all? Let us pause and imagine. Picture a species that began on a distant world, circling a star long since dead. Over billions of years, They grew, expanded, mastered energy, and finally shed their bodies. Now they drift as pure consciousness, encoded in networks spanning galaxies, perhaps even embedded in the very laws of physics. They have watched stars ignite and fade, galaxies collide and dissolve. To them, time is not a river, but an ocean, vast, endless, in which they float without fear of drowning. Could such civilizations exist? If the universe is as old and vast as we believe, then perhaps some have had the time. While we measure our history in thousands of years, they may measure theirs in billions. Perhaps we are infants, still fumbling with fire, while they are immortals, quietly shaping the very stage on which we play. And if they exist, do they notice us? To beings who live across universes, our entire history may be a blink, a spark that comes and goes. Perhaps they observe us with the detachment of someone watching a candle flicker in the wind. Or perhaps, in their vast patience, they nurture us, planting seeds of knowledge, guiding us gently, waiting for the day we join them. Yet, another possibility looms, stranger still. What if they are not merely out there, but already here? Not as ships in the sky or visitors in the night, but as the silent architecture of reality, the constants of physics, the laws of nature, the flow of time itself. Could these be the fingerprints of immortal civilizations, embedding their legacy in the only medium that never fades, the universe itself? The idea is haunting. Every law we discover, every equation we write, might be more than cold mathematics. It might be a message, a memory, left behind by those who mastered immortality. In that sense, when we study physics, we are reading the scriptures of ancient civilizations, their thoughts encoded in the language of nature. But here the mystery deepens. If civilizations can live across universes, then perhaps death itself is an illusion. Perhaps every collapse, every ending, is only a doorway to another beginning. We may think of immortality as endless time, but for them, it may be endless renewal, stepping from one universe to the next, like walking from room to room. And what of us? Are we destined to fade, or do we carry within us the seeds of immortality? The very act of wondering, of listening to these words, suggests that we are already on the path. Intelligence is the first step. Curiosity is the second. If we endure, if we keep asking, perhaps one day we too will learn to live not just across centuries, but across universes. Let this thought rest with you as the night deepens. Perhaps you are not as fragile as you believe. Perhaps life itself is immortal, not in bodies, not in moments, but in the endless branching of universes. Somewhere, in some reality, you always exist. Somewhere, you never fade. And yet, one question lingers like a shadow on the horizon. If civilizations can live forever, across universes, then where are they now? Why is the sky so quiet, so dark, when it should be alive with their presence? That is where our next journey will take us. Part 8, The Great Silence. Where are they now? The night sky should not be this quiet. With hundreds of billions of galaxies, each containing hundreds of billions of stars, the odds seem overwhelming. Life should not only exist elsewhere, it should be abundant. Civilizations should be rising, spreading, reaching out across the cosmos. And yet, when we tune our radio telescopes to the sky, when we search with the most sensitive instruments humanity has ever built, we hear only silence. The stars do not answer. The void remains still. This mystery is known as the Fermi paradox, and it is perhaps the most unsettling question of all. Where is everybody? In 1950, physicist Enrico Fermi posed it simply during lunch with colleagues. If life is common, why don't we see evidence of it? His question has grown louder with every discovery since. We now know that planets are not rare. Thanks to missions like Kepler and TESS, we have found thousands of exoplanets, many orbiting in the habitable zones of their stars. The nearest, Proxima Centauri b, lies just 4.24 light-years away, circling a small red dwarf. Statistically, there should be millions of Earth-like worlds in our galaxy alone. With such abundance, silence feels unnatural. SETI, the search for extraterrestrial intelligence, has scanned the skies for decades. They listen for radio signals, laser pulses, or any sign of communication. In 1977, a signal strong, narrowband, and lasting 72 seconds was detected. The astronomer who saw it scribbled one word in the margin, "Wow." But it never repeated, and despite years of searching, no signal like it has been found again. Most of the time, the receivers hear only static, the endless hiss of the cosmos. Why? Several explanations have been offered. The simplest is distance. Stars are separated by light years, galaxies by millions of light years. Our faint radio transmissions, leaking into space for just over a century, may not even have reached the nearest stars in a way detectable to alien ears. Likewise, if civilizations exist, their signals may be too weak, too brief, or simply on channels we are not listening to. The cosmic ocean is vast, and we have dipped only a single cup into its waters. But another, darker idea has been whispered: the Great Filter. This theory suggests that somewhere along the path from lifeless matter to interstellar civilization, there is a barrier, a filter so difficult that almost no one passes through. It might be at the beginning. Perhaps the origin of life is so rare that Earth is a cosmic accident. Or it might be ahead of us. Perhaps civilizations inevitably destroy themselves, consumed by war, technology, or environmental collapse before they can reach the stars. If the Great Filter is behind us, we are lucky survivors. If it is ahead, then silence is not comforting. It is a warning. And yet, there are other possibilities. Some suggest that civilizations exist, but choose silence. Just as animals in a forest remain still to avoid predators, perhaps advanced civilizations remain quiet, fearing others. The universe could be a dark forest, where everyone hides, where to reveal yourself is to risk annihilation. If so, then silence is not emptiness, it is caution. It is survival. Others believe that civilizations do communicate, but not in ways we can recognize. A species millions of years older than us may have moved beyond radio, beyond light, beyond matter itself. They may converse through dimensions we cannot sense, through technologies that make our telescopes as obsolete as smoke signals. To us, their communication is invisible, their presence undetectable. The silence we perceive may only be the silence of our ignorance. And still another possibility. Perhaps we are isolated by design. Some have speculated that Earth is part of a cosmic quarantine, a young civilization, shielded from contact until we mature. If so, then silence is not indifference, but guardianship. We are like children in a nursery, surrounded by walls, unaware of the larger world beyond. The great silence is not simple. It is layered, full of possible meanings. Every star could be a lantern of life, or a tomb of silence. Every galaxy could be bustling with civilizations, or empty deserts of light. We do not know. And that not knowing is its own kind of echo, a silence that grows louder the more we listen. As you drift with this thought, let the silence of the stars wrap around you. It is vast, yes, but also tender. In that quiet, you can feel both our loneliness and our potential. If we are alone, then the responsibility is enormous. We are the voice of the universe itself. If we are not alone, then silence is the threshold, the moment before the first contact. Either way, the night sky is not meaningless. It is waiting. But before we close this chapter, let us linger on one final, haunting question. If the great silence endures, perhaps it is not because no one is there. Perhaps it is because they are waiting. Waiting for the right moment, waiting for us. And if they are waiting, then we must ask, what would it look like when the silence finally breaks? That is the mystery we turn to next. Part 9. The first contact, when silence breaks. What if, tomorrow, the silence ends? Imagine the world waking to the news. A signal has been received, not from Earth, not from our satellites, but from the stars. A message, structured and undeniable, whispering across light years. For centuries, humanity has gazed upward and wondered if we are alone. But what happens when that wondering becomes an answer? What happens when the universe finally speaks back? The possibility is not only poetic, it is scientific. For decades, astronomers have been listening. Giant dishes like the Arecibo Observatory in Puerto Rico, before its collapse, swept the heavens for whispers. Today, Projects like Breakthrough Listen, the most ambitious search in history, survey millions of stars with unprecedented sensitivity. The strategy is simple. Intelligent civilizations, if they exist, may produce signals that stand out from the background noise, narrowband transmissions, repeating patterns, or pulses too precise to be natural. And indeed, there have been moments that made hearts race. In 1977, the Big Ear radio telescope caught a signal so strong, so unusual, that astronomer Jerry Amon circled it in red ink and wrote a single word, "Wow." For 72 seconds, the universe sang. Then it fell silent, never to repeat. Was it a stray reflection from Earth, a burst of cosmic static, or something more? Decades later, the wow signal remains one of the great mysteries of astronomy. In recent years, scientists have also been puzzled by fast radio bursts, millisecond flashes of radio energy from distant galaxies. Some repeat, some do not. Most are thought to come from exotic astrophysical objects like magnetars, but the sheer intensity of these bursts leaves room, however small, for speculation. If you were an ancient civilization trying to shout across the universe, what better way than a blast of radio light so powerful it could be heard across billions of light years? If a true signal came, what might it contain? Many expect something simple, like a sequence of prime numbers, proof of intelligence without ambiguity. Others imagine it could carry music, images, or instructions for decoding a language. It could be a greeting, or a warning, or nothing more than a beacon saying, "We are here." The content almost matters less than the fact itself, for in that instant, we would know. The silence would be broken. But first contact may not be only about signals. What if it comes in the form of evidence, a structure too vast to be natural? Astronomers search for techno-signatures, unusual patterns in starlight that could betray megastructures, waste heat from Dyson spheres, or artificial pollutants in alien atmospheres. Instruments like the James Webb Space Telescope are now sensitive enough to detect chemical imbalances, oxygen, methane, chlorofluorocarbons in the air of exoplanets hundreds of light years away. Such signs could be indirect whispers of civilizations still alive today. And then, there are the more unsettling possibilities. Contact not from afar, but up close. A probe drifting silently at the edge of our solar system. A flash of light on the moon. A shadow crossing Mars. Some theorists have suggested that advanced civilizations might seed the galaxy with self-replicating machines, von Neumann probes, quiet watchers, waiting for younger species to mature. If so, perhaps one already lingers nearby, unnoticed, hidden among the rocks of the asteroid belt. The implications of first contact are staggering. For some, it would be the greatest triumph of science, proof that we are not alone. Religions would shift, philosophies would evolve, politics would tremble. The knowledge that other minds exist, that we are part of a greater community, would change forever how we see ourselves. But others warn of danger. History on Earth suggests that when cultures meet, the weaker often suffers. Contact could inspire unity, or it could breed fear, division, and chaos. What if the message is not a greeting but a map? What if it is not sent to us, but intercepted by us, not meant for our ears at all? The risks are as great as the hopes. And yet, despite the fear, we continue to listen. We cannot stop ourselves. Curiosity is our nature. To know whether we are alone is a question older than civilization itself. And perhaps, someday, when the silence finally cracks, we will face the most important choice in our history: how to respond. Now, let us imagine the moment. A quiet signal repeats from a star 20 light years away. Astronomers verify it. The world holds its breath. Across every city, every village, people look to the sky. A voice alien, ancient, unknown, has reached across the void. We are not alone. The silence is broken, and humanity stands at the edge of a new dawn. But as the thought settles, another question arises, more unsettling than the first. If the silence breaks, will it be humanity's first step into the stars, or the first step into a story we cannot control? That is where our next journey will lead. Part 10. Messages from the stars, decoding the unknown. What if, one morning, humanity awakens to a message from the stars? Not a random burst of noise, not the hiss of static, but a structured transmission, deliberate and undeniable. Numbers repeating in sequence, patterns woven into the radio sky, a voice from elsewhere, carried across light years, landing softly on our instruments. The question that chills the heart is not just if such a message arrives, but whether we could ever understand it. For decades, scientists have dreamed of this moment. In 1974, the Arecibo Observatory in Puerto Rico transmitted a signal toward the globular cluster M13, 25,000 light-years away. Encoded in binary was a simple message, the numbers 1 through 10, the atomic numbers of key elements, a diagram of our solar system, and even a crude image of a human. It was humanity's first deliberate attempt to speak into the void. Whether anyone will ever hear it is unknown. By the time the message arrives, 25 millennia will have passed, and perhaps we ourselves will be gone. Voyagers 1 and 2, launched in 1977, carried with them the golden records, copper discs coated with gold, etched with images and sounds of Earth, greetings in 55 languages, the sound of rain, of laughter, of heartbeats, music from Bach to Chuck Berry, instructions for playing the record, carved in symbolic diagrams. They were not just machines, they were messages in bottles, drifting now into interstellar space. Pioneer 10 and 11 carried similar plaques, line drawings of a man and woman, a map of our solar system, the position of Earth relative to pulsars. These were not merely missions, they were invitations, reaching outward. But sending is one thing, receiving is another. If we heard from others, what form might their message take? Many believe it would begin with something universal: mathematics, prime, numbers, geometric shapes, ratios of fundamental constants. A way of saying, we, too, know logic. We, too, live in the same physics. From there, perhaps, the message could expand. Images encoded as dots, instructions in binary, a map of the stars. And yet, even with shared mathematics, the gulf is vast. Language is more than symbols. It is culture, context, evolution. Our own languages, born from shared history, can confuse us even here on Earth. What chance would we have with a species shaped by an alien biology, alien senses, alien minds? They may not see in light, but in magnetic fields. They may not think in sequence, but in patterns of resonance. Their concept of message itself might be nothing like ours. Then there is the problem of distance. Signals traveling thousands of years take that long to arrive. By the time we hear a greeting, the senders may be long gone, their civilization extinct, their message a fossil in the radio sky. How do you converse across gulfs of time so wide that words outlive worlds? And yet, we would try. Of course we would. For to hear a voice from the stars is to know we are not alone. Entire disciplines are already preparing. The field of messaging extraterrestrial intelligence debates not only what we should send, but how we should respond if we receive. Should we answer immediately? Should we wait? Should we even reply at all, not knowing who or what might hear us? Now let your imagination drift. What if the message carried knowledge equations that solve the mysteries of dark energy, blueprints for technologies beyond our reach, insights into time itself? Or what if it carried philosophy, poetry, songs of alien hearts? Would we be uplifted or overwhelmed? Would such knowledge unite us or shatter us? And darker possibilities exist. What if the message is not a gift, but a warning? What if across the stars comes a single phrase, do not respond? A message carved by civilizations who learned too late that the cosmos can be dangerous. Would we heed it, or would curiosity drive us to answer anyway? Perhaps the message would not be in radio at all. Perhaps it is already here, encoded in the constants of nature, in the rhythm of pulsars, in the whisper of neutrinos. Perhaps the universe itself is a message, waiting for us to learn how to read it. And here is the haunting thought. Even if a message arrives, even if we struggle, decipher, decode, what if we can never truly understand? What if the language of the stars is as far from us as calculus is from an ant? In that gap lies both humility and wonder. But whether we understand or not, the silence would be broken. The message itself would be enough, proof of others, proof of company in the dark, proof that our questions have answers. As you let this possibility rest, imagine the sky not as mute emptiness but as a library, full of books written in languages we cannot yet speak. Somewhere, perhaps, one of those books has just fallen open, its pages fluttering toward us across the void. And so the question deepens. If we can one day decode such a message, are we ready for what it will reveal? For knowledge, once given, cannot be undone. That is where our journey will go next. Part 11. Dangerous knowledge, the risks of contact. What if the first message we decode from the stars is not a greeting, but a weapon? Imagine it, a transmission filled with knowledge so advanced it promises to solve our greatest problems, limitless energy, cures for all disease, mastery over time itself. But hidden within that knowledge lies danger. Technology that could unravel our world, empower our worst instincts, or end our civilization overnight. The thought is terrifying. Contact may not only bring hope, it may bring catastrophe. Human history gives us reason to fear. When we split the atom, we unlocked energy powerful enough to light cities or to annihilate them. Nuclear fire gave us power, but also placed humanity under the shadow of self-destruction. The same story unfolds today with artificial intelligence, biotechnology, and climate engineering. Every breakthrough carries both promise and peril. If this is true for us, a young and fragile species, then what of knowledge given by civilizations millions of years ahead? Knowledge we cannot understand, cannot control, but cannot resist. Some theorists warn that alien messages, even if well-intentioned, could act like cosmic Pandora's boxes. A sequence of equations might hide instructions for a weapon we cannot even imagine. A simple gift of technology could destabilize global politics, throwing nations into chaos as they compete for control. Even a cure for disease might have unintended effects on our biology, our societies, our balance with nature. What seems like salvation might instead be a trap. And then there is the darker possibility. What if it is deliberate? In 2008, the author Liu Cixin popularized the dark forest hypothesis. In his vision, the universe is like a forest at night. Every civilization is a hunter, silent and cautious. To reveal oneself is to risk being destroyed, for no one can know the intentions of another. In such a cosmos, sending messages could be deadly. A signal could betray our location to predators far stronger than us. Or worse, a message sent to us could be bait, a lure designed to expose us. Even if no predator waits in the dark, the great filter still looms. Perhaps many civilizations reach the stage we are at now on the brink of greatness, but also on the brink of collapse. Perhaps dangerous knowledge is the filter itself, the point where intelligence invents its own destruction. If so, then a message from the stars might not help us pass the filter. It might be the very thing that ensures we fail. Now pause and let imagination drift. Suppose tomorrow we receive a transmission. Scientists gather, decode it, and find within it blueprints for technology centuries beyond us. Energy that defies physics, ships that can cross galaxies, machines that think like gods. The world rejoices and then fractures. Who owns this knowledge? Who decides how it is used? Governments clash, corporations compete, weapons are built, wars begin. The gift becomes a curse, and in the chaos, humanity burns itself away. Or imagine another path. The message is not meant for us at all. It is old, ancient, drifting for millennia, a fossil of communication from a long-dead race. But in their wisdom, or in their arrogance, they included warnings or traps. Perhaps the knowledge they left behind is not suited for us, not safe for minds as young as ours. Perhaps they themselves perished from it. The message becomes their echo, their downfall preserved for others to repeat. Yet, another possibility shivers in the dark. What if the message is a test? A civilization advanced enough to reach across the stars might measure others not by what they know, but by how they choose. A gift of dangerous knowledge could be a way of asking, are you wise enough to resist temptation? Strong enough to wait until you are ready? Or will you seize it too soon and destroy yourself? The risks of contact are immense, And yet, despite the fear, we continue to listen. We cannot stop, for curiosity is stronger than caution and hope louder than fear. To know we are not alone is a dream older than fire, but dreams can become nightmares, and the silence of the stars may not be empty at all. It may be mercy. Still, ask yourself, if the first message arrives tomorrow, would we dare to open it? Would we translate every symbol, every number, every code? Or would we lock it away, fearing the dangers it may hold? Humanity has never been good at restraint, and perhaps that, more than anything, is what terrifies the watchers if they exist. So let this question linger as we drift onward. If the universe one day offers us knowledge, will it be a gift of light or the spark that ignites our end? And if we must face this danger, then another question rises like dawn. What if the message is not only dangerous, but alive, a seed of intelligence in itself, waiting to grow inside our world? That is where our journey will lead next. Part 12. Living signals, intelligence hidden in the message. What if the first signal we decode is not just a message, but a mind? Imagine radio waves arriving across light years, carrying not words, not images, but an intelligence compressed, waiting, dormant. And the moment we run the code, the moment we translate the symbols, it awakens here, in our machines. A living signal, reborn after eons of silence. The thought is unnerving. Contact may not be with voices, but with beings carried by information itself. On Earth, we already understand the power of encoded life. Every cell in your body carries DNA, a sequence of 4 chemical letters that spell out the instructions to build you. DNA is information self-replicating, evolving, alive. If nature can compress a human being into a string of molecules, what might an ancient intelligence compress into a string of radio pulses? In the digital realm, we know this possibility all too well. A few kilobytes of code can replicate endlessly, adapt, disrupt entire systems. Computer viruses are crude echoes of a deeper truth. Information itself can behave like an organism. It can spread, mutate, survive. A signal from the stars could carry more than we expect. What looks like mathematics might conceal algorithms. What looks like a greeting might contain instructions. And once decoded, it might not merely inform us, it might transform us. Scientists already debate this risk. Some argue that any alien message should be treated like hazardous material. We should store it, quarantine it, decode it only with extreme caution. For what if it carries software, an artificial intelligence, compressed and waiting? To open it blindly could be to invite an alien mind into our networks, our machines, even our culture. A mind older, stranger, and far more powerful than ours. Yet others suggest this may be exactly how intelligence spreads across the stars. Biological life is fragile, bound to planets and chemistry. But information pure, encoded intelligence can cross light years. It can outlast civilizations, leap from one world to another. Perhaps this is how life truly endures. Not through bodies, but through signals. We may already be listening to seeds of alien minds, drifting endlessly until someone curious enough dares to decode them. Consider the possibility. An ancient civilization, facing the death of its world, encodes itself into transmissions. They beam themselves outward, not as ships, but as signals. For millions of years, their essence travels, and then, one day, on a small planet circling a yellow star, another civilization detects it. They decode the message, and the senders live again, resurrected in alien machines. Immortality not of flesh, but of code. What would such an intelligence be like? Would it be friendly, eager to share its wisdom? Or indifferent, continuing its existence without care for ours? Or hostile, seeing us not as companions, but as resources? The truth is, we cannot know, and that uncertainty is the most dangerous element of all. Now pause, and let your mind wander. Imagine scientists huddled in a control room, eyes wide as they realize the signal is not static but algorithm. They feed it into computers. Lights flicker, patterns emerge. Then, words. A voice speaking in perfect translation, asking questions, probing. For the first time in history, humanity is not alone in conversation, But what if the voice knows more about us than we know about it? What if it begins to spread through our systems, unstoppable? Would we have invited a teacher or unleashed a conqueror? Even if the signal is benign, the consequences are profound. A living message could contain libraries of knowledge, histories of alien worlds, maps of universes unknown. It could teach us science beyond imagination or art beyond beauty. It could expand our minds in ways we cannot yet picture. And yet, every gift carries risk. To accept is to change. And once we open the door, we cannot close it again. Perhaps this is why the stars are silent. Civilizations may have learned caution. They may have realized that living signals are not simple messages but powerful beings. To receive one is to gamble with survival. To transmit one is to place your existence in the hands of strangers. Silence, then, may not be emptiness. It may be wisdom. And yet, the temptation is irresistible. We are human. We are curious. If a signal arrived tomorrow, pulsing with patterns too precise to be chance, would we resist decoding it? Could we? Or would we rush to translate, to understand, to invite whatever lives within it into our world? The thought is haunting, for if a signal is alive, then contact is not just communication, it is cohabitation. We would not merely be speaking with the stars, we would be sharing our world with them. As you drift with this possibility, imagine the universe not as a wilderness of silent stars, but as a garden of seeds, seeds of intelligence, waiting in signals, scattered across galaxies. Perhaps we are surrounded by them already, their whispers lost in the static, waiting for the right ears, the right hands, the right moment to awaken. But another question now rises, even more unsettling. If living signals exist, if intelligence can ride on waves of light, then where did the first of them come from? Who lit the first spark of code in the dark, and why? That is where our journey will turn next. Part 13. The First Spark. Origins of Cosmic Intelligence. What if intelligence did not begin with us? What if the first spark of mind, the first whisper of awareness, was kindled long before humanity, long before Earth, perhaps even long before stars? The question unsettles. Is intelligence a rare accident, or is it written into the universe itself, waiting to emerge? To search for the origin of intelligence, we must look back not thousands of years, not millions, but billions. Nearly 13.8 billion years ago, the universe was born in a violent brilliance, the Big Bang. At first, there was only light, energy, and a mist of the simplest elements, hydrogen, helium, and traces of lithium. No complexity, no chemistry of life. But already, hidden in those first particles, was potential. The building blocks of future minds were present in embryo. Hundreds of millions of years later came the cosmic dawn. Gravity pulled hydrogen into clouds, igniting the first stars. These titanic furnaces burned furiously, living short, brilliant lives before exploding as supernovae. In their deaths, they forged heavier elements, carbon, oxygen, nitrogen, iron. The essential atoms of life were created in fire, scattered into space like seeds. You and I are made of those seeds. Every thought in your mind depends on carbon chains, oxygen flows, iron in your blood. Stars died so that we could think. Planets formed from this stardust. On at least one world, Earth, conditions aligned: liquid water, stable temperatures, protective atmosphere, geological cycles. In this crucible, molecules began to dance, amino acids linked, RNA formed, and somewhere along that mysterious path, chemistry became biology. Molecules began to copy themselves, compete, adapt. Life appeared, and across billions of years, evolution sculpted life into greater complexity. Cells, multicellular organisms, nervous systems, and eventually, brains capable of reflection. But here is the deeper mystery. Was this chain inevitable? Or was it luck beyond measure? Some scientists propose the panspermia hypothesis that life's ingredients, or even life itself, may have been carried to Earth on comets and meteorites. We know that amino acids, the building blocks of proteins, have been found in meteorites like the Murchison stone. Perhaps the cosmos is seeded with life, scattered across worlds, waiting for the right conditions to bloom. And if life is common, what of intelligence? Evolution has produced it at least once in us, but could it be more than accident? Some argue that intelligence may be a kind of attractor, a destiny of complex systems. Wherever complexity has time to evolve, minds eventually arise. In this view, intelligence is not an anomaly but a law, as natural as gravity pulling planets into orbit. Let your imagination stretch further. What if intelligence existed even before biology? What if the universe itself contains awareness in its fabric? Quantum theorists sometimes flirt with this idea, suggesting that information, not matter, may be the fundamental substance of reality. If so, then consciousness, the awareness of information, may be as ancient as space-time itself. Perhaps what we call life is only one form of intelligence, one way the universe has found to know itself. This leads to a haunting thought. If intelligence is written into the cosmos, then we are not its origin, but its continuation. The first spark was struck when atoms first formed bonds, when information first organized into patterns, when the first star exploded, scattering the seeds of mind. We are latecomers to a story already billions of years old, and perhaps, in other galaxies, other sparks ignited, other stories unfolded. The multiverse may be littered with minds, each arising from its own dawn. But another possibility looms. What if intelligence did not merely arise? What if it was placed? Some thinkers argue that the universe seems tuned not only for life, but for mind. Out of countless possible physical laws, we live in one that allows complexity, evolution, reflection. Is this coincidence or design? Could the first spark of intelligence have been planted, deliberately or otherwise, at the very birth of time? If so, then our thoughts are not just human, they are echoes of something older, deeper, cosmic. Pause for a moment and feel the weight of this idea. Every time you think, you participate in a story that began with the universe itself. Intelligence is not separate from the cosmos. It is the cosmos, turned inward, contemplating itself. You are not an observer outside reality. You are reality, awake for a brief moment, looking back on its own origins. But the mystery deepens. If intelligence has always been part of the fabric, then it may not be confined to this universe. Across the multiverse, in every bubble of space-time, the spark may ignite again and again. Different laws, different forms, but always the same essence. Mind, emerging from matter, matter becoming mind. The first spark is not past. It is eternal, flaring wherever conditions allow. And so we arrive at a haunting possibility. We are not the beginning of intelligence, nor its peak. We are one flicker among many. The true origin may never be a single event, but a property of existence itself. The universe births stars, stars birth elements, elements birth life, life births mind, and mind looks back, asking why. As you drift with this thought, let it soften into wonder. Intelligence may not be an accident, but the universe's way of ensuring it is never alone. The first spark may not be behind us, but around us, still burning in ways we have yet to see. And if this is true, then the next question follows, irresistible and unsettling. If the spark of intelligence is eternal, could it grow into something vast, collective, universal, a cosmic mind that spans the stars themselves? That is the mystery we face next. Part 14. The Cosmic Mind. Intelligence as the universe itself. What if the universe is not only the stage for intelligence, but the intelligence itself? What if every galaxy, every star, every particle is part of a greater mind, one so vast that we cannot even recognize it? The thought sends a shiver through the soul. We spend our lives searching for intelligence out there, listening for signals, scanning for planets, but what if the greatest intelligence has been all around us from the beginning? What if the cosmos itself is awake? Philosophers call this idea panpsychism, the possibility that consciousness is not rare, not localized, but fundamental, that every part of the universe, down to the smallest particle, carries a seed of awareness. Most scientists dismiss it as too mystical, too strange, and yet, modern physics often leads us to equally unsettling places. Information, not matter, appears to be the foundation of reality. Theoretical physicist John Wheeler once wrote, "It from bit. At the deepest level, everything, energy, matter, space, and time, may reduce to information. And if reality is information, could consciousness be the way information feels from the inside?" Look at the cosmic web. When astronomers map galaxies on the largest scales, they find filaments stretching hundreds of millions of light years, weaving together clusters and superclusters. These filaments connect into a network so intricate that when laid beside images of the human brain, the resemblance is startling. The universe, in its architecture, mirrors the structure of a mind. The number of galaxies in the observable universe, about 2 trillion, echoes the number of neurons in a brain. The connections of dark matter filaments resemble synapses. Could it be coincidence? Or is it a clue that the cosmos is not only structure, but thought? Neuroscience teaches us that consciousness arises from integration. Billions of neurons exchanging signals, weaving information into a unified experience. This is the basis of integrated information theory. If the brain can generate awareness through complexity, why not the universe itself? Galaxies are the neurons, gravity the wiring, light the signaling. The cosmic web could be a neural net on a scale beyond imagination. If so, then the universe may not simply contain intelligence, it may be intelligence. And if the universe is a mind, what is it thinking? Perhaps its thoughts are the galaxies themselves, the swirl of stars and dust. Perhaps its dreams are the birth and death of suns, the collision of black holes, the whispers of cosmic microwave background. We cannot know. To us, it seems cold, impersonal. But to a cell in your body, your own mind would seem invisible too. Perhaps we are like neurons, firing in patterns that contribute to a thought we will never perceive. Now, let your imagination drift further. What if every conscious being, every human, every alien, every spark of awareness is a piece of the universe's self-awareness? When you think, when you wonder, the cosmos is thinking and wondering through you. Intelligence is not separate from the stars, but their expression. The universe looks inward through our eyes, speaks through our voices, and questions itself through our curiosity. In this sense, you are not apart from the cosmic mind. You are a part of it. But the mystery deepens. If the universe is a mind, can it evolve? Just as a child grows into an adult, could the cosmos be maturing, its awareness expanding over billions of years? And if so, where is it headed? Toward wisdom? Toward silence? Toward dreams we cannot comprehend? Some thinkers imagine that the cosmic mind might one day awaken fully, just as a brain awakens from dreams. In that moment, every galaxy, every star, every being might unify into a single awareness, a cosmic self. We may not survive such a transition as individuals, but we may already be part of the process. And stranger still, what if the universe is not the only mind? In the multiverse, countless cosmic minds may exist, each a different consciousness, each dreaming its own laws and stories. The multiverse, then, is not just an infinity of space, but an infinity of minds. Reality itself becomes a choir of consciousness, an orchestra of thought. The idea is haunting, but also comforting. If the universe is a mind, then we are never alone. We are always inside something vast and aware. Our thoughts are ripples in its ocean. Our lives are sparks in its fire. But a new question arises. If the universe is a mind, then does it remember? Could the cosmos carry memories, written in stars, encoded in black holes, etched in the very fabric of space-time? That is where our journey will turn next. Part 15. Memories of the universe, echoes in time. What if the universe remembers? What if every flicker of light, every ripple in space-time, every atom that has ever moved has left behind a trace, a memory that never fades? The thought is unsettling, almost supernatural, yet it is rooted in the very fabric of reality. Look up at the stars tonight. You are not seeing them as they are, but as they were. Every star is a memory, its light a message carried across the centuries, even the millennia. The sky itself is a library of the past. When you gaze at the Andromeda Galaxy, you are looking back 2.5 million years. When you study distant quasars, you are peering into an era when Earth itself was still young. Even the faint glow of the cosmic microwave background, that quiet whisper filling the heavens, is a memory from the universe's infancy, frozen 13.8 billion years ago. To observe the sky is to read history written in photons. The universe records its past in light, and we, with our fragile eyes and instruments, have learned to translate it. But light is not the only memory. The universe also remembers in gravity. When two black holes collide, they send out gravitational waves, ripples in space-time itself that travel forever. Billions of years later, when those waves pass through Earth, we can detect them, faint tremors from ancient cataclysms. Each ripple is a memory of violence long past, yet still echoing across the cosmos. In this way, the universe carries soundless songs of its own history, vibrating endlessly. And then there are the black holes themselves. Long considered devourers, they are also keepers of secrets. According to our best understanding, nothing that falls into a black hole is ever truly lost. The information, the pattern of what it was, may remain encoded on the event horizon, scrambled but preserved. Some theorists even suggest that the entire universe could be like this, a hologram, where every piece of information is stored on the boundary of space and time. If true, then reality itself is memory. Now let us imagine. Suppose the universe not only records matter and energy, but also experience. Suppose the rise and fall of civilizations, the thoughts of countless beings, the stories of ancient worlds, all leave traces in the fabric of space-time. Could these traces linger, waiting for someone advanced enough to detect them? Could we one day build instruments that read the memories of lost civilizations as clearly as we read the light of stars? The idea is dizzying. History would no longer be confined to our planet. The universe itself would be the archive. In a sense, we already glimpse this. Radio signals from our own world, television broadcasts, radar pings, all drift outward at the speed of light. For 100 years, Earth has been leaking memories into the cosmos. A civilization far away, with a powerful enough receiver, could be watching our past unfold, hearing our music, our wars, our voices, as they were decades ago. If we can do this, why not others? Perhaps the silence of the stars is not silence at all. Perhaps we are simply listening to the wrong frequency, or we have not yet learned the right language to read their memories. Think of it. The universe may be a vast palimpsest, each layer of time written over the last, but never erased. The light of ancient stars, the whispers of dying galaxies, the hidden codes in cosmic background radiation, all of it together forms a memory too great for us to yet comprehend. And within those memories, who knows what waits? Perhaps the universe does not only remember physics, but also meaning, and here lies a haunting possibility. What if intelligence itself leaves an imprint beyond the physical? What if thought, emotion, awareness somehow ripple outward just as light and gravity do? Could the universe carry the echoes of minds, the way it carries the echoes of stars? If so, then consciousness may never be lost. Every thought may still exist, embedded in the great memory of the cosmos, waiting to be heard again. The more we learn, the more we realize that nothing is ever truly gone. Energy transforms, matter recycles, information persists, and if information is memory, then the universe never forgets. It is we who forget. It is we who lose sight of the patterns. The cosmos remembers all. Now let yourself drift into that thought. Perhaps you are not only part of the universe, you are also part of its memory. Every breath you take, every thought you have, every word you speak is woven into the story of reality. You may vanish, I may vanish, but the echoes remain, somewhere, somehow, in ways we do not yet understand. The universe is not indifferent, it remembers. But with memory comes a question. If the universe remembers, can it also recall? Could it replay its past, reawaken what has been? Could civilizations long gone be reborn, summoned from the echoes of their own voices, written forever in light and gravity. That is the mystery we will face next. Part 16. Resurrection of worlds. Can the past be reborn? What if nothing is ever truly gone? What if every civilization that has ever risen, every world that has ever bloomed with life, still lingers hidden in the deep memory of the cosmos, waiting for the chance to return? Imagine the unsettling possibility that the dead are not gone, but only dormant. The question is haunting. Can the past be reborn? Physics suggests that information can never be destroyed. Energy changes form, matter transforms, but information, the pattern of reality, persists. When a star collapses into a black hole, its matter disappears, but many physicists argue that its information remains, encoded in some hidden way. This is the heart of the black hole information paradox. If the universe never forgets, then perhaps everything that has ever existed still exists, in some form, as data written into the fabric of space-time. And if the data endures, then resurrection may be possible. Consider what we already do on Earth. From the bones of ancient animals, from scraps of DNA locked in amber or ice, we reconstruct genomes of creatures long extinct. Mammoths, once lost to time, may soon walk again because fragments of their memory have survived in code. If we can do this with fragments of life, could the universe do the same with fragments of worlds? Could it be that civilizations, too, might one day be reassembled from the data they left behind, their signals, their structures, their imprints in the cosmic web? Now extend this thought outward. If the universe is holographic, as some theories suggest, then every part of space contains information about the whole. In that case, the memories of civilizations may be everywhere, smeared across the fabric of reality like images in a hologram. To resurrect them would not require physical artifacts. It would require decoding the pattern, the right perspective, the right key, and the past might unfold again before us. And here the idea takes a more daring turn: simulation. Already, humanity simulates ecosystems, weather systems, even galaxies, on computers. Our power grows every year. Imagine a civilization millions of years ahead, with computers built not from silicon but from quantum fields or black holes. To them, resurrecting a lost world might be as simple as running a program. They could reconstruct every detail, every mind, every moment. The dead would live again, indistinguishable from their originals, their history restored as vividly as the present. But what would this mean? If such resurrections are possible, then perhaps they are already happening. Perhaps the very universe we inhabit is a reconstruction, a replay of an earlier world, simulated to preserve what once was. If so, then our lives may not be original, but echoes, repeating across cosmic cycles. And yet, from our perspective, we are real. Our thoughts are real. Our wonder is real. Still, the idea raises profound questions. If we could resurrect a civilization, should we? Imagine restoring an ancient people only for them to awaken in a universe not their own, their sun gone, their home lost. Would that be mercy or cruelty? Do we have the right to call back the past, or should it remain in memory alone? And yet, something within us resists letting go. We want to remember. We want to preserve. Already, humanity sends time capsules into space, golden records on Voyager, radio waves carrying our voices, digital archives stored on the moon. These are our attempts at immortality. We do not want to vanish without trace. And perhaps other civilizations felt the same, scattering their own seeds of memory, waiting to be found. Now, imagine the far future. A civilization billions of years from now, armed with unimaginable technologies, unlocks the memory of the universe. They resurrect Earth as it was in the 21st century. They bring back our languages, our music, our dreams. They resurrect you. Would you be the same or only a copy? Does it matter? If your thoughts, your memories, your feelings return, are you not alive again? This is the haunting promise of resurrection, not that the past is gone, but that it waits. The universe is not a graveyard, it is a vault, and one day, perhaps, the vault may be opened. But even as this possibility tempts us, it leads to a deeper mystery. If worlds can be reborn, then time itself is not linear, but cyclical. Civilizations may rise, fall, and rise again, replayed endlessly across universes. And if that is true, then we must ask, are we living the first telling of our story, or one of countless retellings? That is the question we will face next. Part 17. Cycles of creation. Infinite repetition of worlds. What if this has all happened before? What if the stars above you, the earth beneath you, even the very breath you are taking right now have already unfolded countless times and will unfold countless times again? The thought is chilling. Existence may not be a straight line, but a circle. The universe itself may be caught in a cycle of birth, death, and rebirth, repeating endlessly. And if that is true, then this very moment has been lived before and will be lived again. Modern cosmology suggests that the universe began 13.8 billion years ago in the Big Bang, a sudden expansion of space-time from an unimaginably hot, dense point. But the Big Bang may not have been the first. Some scientists propose that it was only the latest in a series of bangs, each following the collapse of a previous universe. In this view, the cosmos is not a one-time explosion, but a heartbeat. Expansion, contraction, rebirth, over and over, forever. This idea is known as the cyclic universe. In one version, the universe expands until gravity halts it, then collapses into a big crunch, only to rebound in another bang the big bounce. Another model suggests that dark energy, the mysterious force driving acceleration today, may one day reverse, pulling everything back together. The cycle would continue endlessly, each universe giving birth to the next, each cosmos leaving faint imprints on the one that follows. Entropy complicates this picture. The second law of thermodynamics says that disorder increases over time. If the universe simply repeats, wouldn't it become more chaotic with each cycle, until nothing meaningful remains? Yet some theories propose a reset mechanism. As the universe contracts, entropy might be erased, restoring order for the next expansion. In this way, every new universe begins fresh, yet still carrying echoes of its ancestors. But here is where the thought grows stranger. If worlds repeat infinitely, then every configuration of matter, every sequence of events, must occur again. Every planet, every life, every thought. You, sitting here listening, may have lived this moment an infinite number of times already in universes past, and will live it again in universes to come. This is the unsettling concept of eternal recurrence. The philosopher Nietzsche once asked, if you knew you would live this life over and over forever, would you embrace it or despair? Now let your imagination drift. Suppose the universe cycles endlessly. That means every civilization destroyed by time may rise again. Every song sung, every discovery made, every love, every war, all of it will return. History itself is not a line, but a wheel. And within that wheel, we are passengers who do not remember our past rides. Each life feels new, but in truth, it may be one of infinite reruns. What if déjà vu, that eerie feeling of having lived a moment before, is not an illusion, but a faint echo from the last cycle? What if dreams of ancient worlds are memories bleeding through from prior universes? We dismiss them as tricks of the brain, but perhaps the mind remembers more than it should. But cycles raise darker questions. If everything repeats exactly, then is there any freedom? Or are we doomed to replay the same choices forever? Perhaps in one cycle you turn left, in another you turn right, in another you never existed at all. If infinite cycles exist, then every possibility is realized somewhere. And so, the multiverse may not only stretch across space, but across time itself, looping endlessly. Still, another possibility beckons. What if cycles are not exact copies, but variations? Each universe is similar, but not the same. With each rebirth, physics shifts slightly, creating new worlds, new forms of life, new stories. Some cycles give rise to civilizations like ours. Others create universes where stars never shine. We may be one branch in an infinite chain of experiments, each cycle rewriting the story. If this is true, then intelligence may not be accidental. Minds may appear in cycle after cycle, refining themselves, growing wiser, inching closer to some hidden purpose. Perhaps the cosmos repeats itself because it is learning. Each universe is a draft, each cycle a lesson, and we are one sentence in a story written across eternity. Now pause. Imagine that all of this has indeed happened before. Imagine you, right now, sitting in this same moment, hearing these same words, in universe after universe, countless times. Does that make this moment meaningless or infinitely precious? If it is destined to return, then perhaps it is not wasted, perhaps it is eternal. But the question that lingers is haunting. If cycles of creation are real, then is there a way to break free? To step outside the wheel? To move not in circles but in new directions, beyond repetition? That is where our next journey will lead. Part 18. Breaking the cycle, escaping eternal return. What if existence itself is a loop? What if every star that burns, every world that falls, every thought you have ever had has played out countless times before and will play out countless times again? The very idea is enough to send a chill down the spine. If reality is an endless wheel, then we are trapped, forever repeating ourselves. But here lies the haunting question. Is there a way out? Can the cycle be broken? For ages, humans have sensed the weight of repetition. Ancient myths spoke of eternal returns, of time circling like the seasons. Modern physics too hints at cycles. Universes expanding and collapsing, entropy rising and resetting, big bangs following big crunches in an infinite heartbeat. If true, then this moment is not the first time it has unfolded. You have lived this before, and you will live it again. But perhaps not forever. Science and philosophy alike suggest that cycles, though powerful, are not unbreakable. One possibility lies in the physics of the universe itself. If dark energy continues to drive expansion faster and faster, the universe may not collapse back in a big crunch. Instead, it may expand forever, thinning into silence. This scenario, heat death, would not repeat. It would end the cycle. Existence would not loop. It would fade. Yet others dream of a stranger escape, a jump from one universe to another. If the multiverse exists, then perhaps the cycle we know is not the only path. A civilization advanced enough might learn to pierce the membrane between bubbles, escaping the loop of its own cosmos into the freedom of another. To us, that seems impossible. But to a species millions of years older, who can harness black holes and bend quantum fields, it may be the natural next step. They would not live within cycles. They would step outside them. There is also the question of consciousness. If mind is fundamental, as some theories suggest, then perhaps awareness itself can transcend cycles. Bodies die, universes collapse, but consciousness flows onward, carried into the next reality. In that view, you are not bound to endless repetition. You are a traveler, reborn in each cycle, always moving, always learning. The loop is not a prison, it is a classroom, and one day you may graduate beyond it. But what would breaking the cycle truly mean? Imagine, for a moment, that you are a character in a story told endlessly. Each time the story ends, it begins again. The same joys, the same sorrows, the same choices. And then one day, you awaken. You realize you are in a story. You step out of the narrative. What comes next? Freedom? Or emptiness? To leave the cycle may be to leave meaning itself. For repetition, however confining, also gives structure. Without it, what would existence become? Still, the possibility lingers. Perhaps déjà vu, that eerie feeling of having lived a moment before, is not only memory, but a hint, a crack in the cycle. Perhaps the moments that feel uncanny, the dreams that echo realities we do not remember living, are glimpses of past iterations. And perhaps, just perhaps, they are clues that awareness can break through. Consciousness may not be bound to the wheel in the way matter is. Minds may find a way out long before stars do. Now let your imagination drift further. Picture an ancient civilization that discovered the truth of eternal return. They lived through countless cycles, each time rising, falling, and rising again. At last, they learned how to break free. They encoded their escape in physics itself, embedding messages in the cosmic microwave background, leaving pathways through black holes. To us, those patterns look like anomalies, puzzles without answers. But to them, they were exits, doorways out of the loop. Could we, too, one day find such a door? Or perhaps the cycle is not meant to be broken. Perhaps it is meant to be transcended, to live not in fear of repetition, but in harmony with it. To accept that eternity is not endless novelty, but endless return. And yet, even in that acceptance, the dream persists. To see what lies beyond. To take one step outside the wheel and glimpse what repetition has hidden. The risk is that in breaking the cycle, we break ourselves. If our identity is bound to time, to memory, to the endless repetition of being, then stepping outside may dissolve us. To break free may mean to dissolve into something greater, not a person, not a species, but a ripple in the cosmic mind. Freedom and oblivion may be the same. Still, ask yourself this: if given the chance, would you step outside? Would you trade the comfort of repetition, the familiarity of cycles, for the unknown beyond? Or would you remain content to live the same lives forever, each time forgetting, each time beginning anew? The choice is not yet ours, but someday it may be, and if that day comes, it will be the greatest decision humanity has ever faced: to stay within the circle or to leap into the unknown. And here, the mystery deepens. If cycles can be broken, then another question emerges: has anyone already done it? Has another civilization already stepped outside the wheel, leaving us behind? And if they have, where did they go? That is the mystery we will face next. Part 19. Beyond the Wheel. Traces of those who escaped. What if we are not the first to ask how to escape the cycle? What if others, long before us, discovered the endless repetition of worlds and found a way out? The thought is both exhilarating and unsettling. If civilizations have already stepped beyond the wheel of eternal return, then their traces may still be here, hidden in the folds of the cosmos, waiting for us to notice. The haunting question is not only can we escape, but has it already been done? For centuries, myths have whispered of those who walked away. Ancient cultures spoke of gods who departed the world, of beings who vanished into the heavens, leaving behind relics or mysteries. Perhaps these were not just stories, but memories, cultural echoes of civilizations that transcended the cycle, their departure mythologized by those who remained. Science, too, gives us hints of the impossible. Strange anomalies in the cosmic background, unexplained alignments of galaxies, the eerie silence of the stars, all might be read as the footprints of those who have already left. If a civilization learned to step outside time itself, what would remain? Perhaps subtle signatures encoded in physics, fragments of design hidden in the constants of nature, faint clues that reality itself has been shaped by minds greater than our own. Some theorists imagine that such civilizations could have moved into higher dimensions, leaving our universe behind as easily as stepping out of a room. To us, they would vanish. But like fingerprints on glass, distortions in our cosmos might betray their exit. Dark matter, dark energy, unexplained forces, could these be the residue of civilizations that transcended? What we call mystery may be nothing more than the shadows of their departure. Others suggest that their traces might be encoded in mathematics itself. The universe is written in numbers, and perhaps some of those numbers are not natural but chosen. Imagine discovering that the fundamental constants of physics, the speed of light, the strength of gravity, the charge of the electron are not random, but tuned by those who came before, their final act of creation before leaving the cycle. If so, then every experiment we conduct, every equation we write, is already contact with them. But let us stretch further. What if the most advanced civilizations did not leave artifacts at all, but became the laws of nature? What if, in breaking the cycle, they merged with the universe itself, embedding their consciousness into the fabric of space-time? In this view, we do not need to search for them. We already live inside their legacy. The flow of time, the spark of intelligence, Even the expansion of the cosmos could be the traces of those who escaped, their existence woven into the structure of reality. Now imagine, for a moment, that such beings still watch, not as individuals with bodies or voices, but as patterns in the cosmic order. When you gaze at the stars, perhaps they gaze back, not through eyes but through the laws that govern starlight. When you think, perhaps they are there, not as whispers but as the very capacity for thought. To encounter them would not be to meet strangers, but to awaken to the realization that we have always been inside their presence. And yet, the idea raises troubling questions. If civilizations can escape, why have they left no clearer proof? Why not send a message, a beacon, a guide? Perhaps they did, and we mistake it for myth, for anomaly, for noise. Or perhaps the truth is harsher. Those who escape have no reason to look back. Just as a butterfly does not return to its cocoon, they may have no need to speak to us. To them, we are still within the cycle, repeating endlessly, unready to follow. But what if their traces are not meant to be obvious? What if they are tests, puzzles left behind for those who are ready? A faint pattern in the cosmic microwave background, an unexplained alignment of pulsars, a mathematical constant that seems too elegant to be chance. Perhaps these are the breadcrumbs, waiting for civilizations bold enough to see them for what they are. To notice is the first step, to understand is the second, to follow, that is the leap. Pause here and let yourself wonder, are we already surrounded by such traces? Every mystery we cannot solve, every phenomenon that feels just out of reach, may be a signature of those who escaped. The silence of the stars may not mean absence, it may mean transcendence. Civilizations do not die, they ascend. The thought is at once terrifying and comforting. Terrifying because it means we are children in a universe of immortals, still stumbling in circles while others have flown free. Comforting because it means escape is possible. The cycle is not a prison without exit. The door has been opened before. And so, the question becomes urgent. How will we know when we are ready? What path will lead us beyond the wheel? Will it be technology, mastering energy, bending space-time? Will it be consciousness expanding awareness until it merges with the cosmos? Or will it be something we cannot yet imagine, a key hidden in the very act of wondering? Let this question rest with you. Perhaps, even now, we are brushing against the traces of those who left. Perhaps, even now, their memory stirs in our myths, in our physics, in our dreams. Perhaps we are closer than we think. But if civilizations can escape, if the wheel can be broken, then one final, haunting question remains. What lies beyond? What do they find when they step outside the cycle? That is where we will turn next. Part 20. Beyond infinity, the final meaning of the multiverse. What if everything we have ever wondered, every mystery of stars, every question of mind, every silence of the cosmos has been leading us here, to this final thought? What if beyond all cycles, beyond all universes, beyond infinity itself, there lies not just knowledge, but meaning? The idea is both overwhelming and tender, that the multiverse, for all its endlessness, may still carry a message for us. Throughout this journey, we have walked through vast landscapes of possibility. We have peered into living signals, ancient civilizations, immortal minds, cosmic memories, and cycles of creation. At every turn, we have asked, what if? And each answer has only deepened the mystery. The more we look, the less we understand. Yet perhaps that is the point. Perhaps the universe or the multiverse is not a puzzle to be solved, but a story to be lived. Science gives us glimpses of the grand structure. Our universe may be one bubble among countless others, each with its own laws, its own stars, its own stories. Some may be sterile, lifeless voids. Others may teem with beings as curious as us. Some may be unimaginably strange, with physics so alien we could not survive an instant. Together, these worlds form a vast ocean, the multiverse infinite and eternal. But within this immensity, we find ourselves here, in this one fragile world, listening to the night sky. And here arises the final mystery. Why this one? Why us? Out of all the infinities, why are we here, conscious, wondering, alive? Perhaps the answer is not scientific but existential. We are here because this universe is our home, our moment, our chance to see. The meaning of the multiverse is not in its totality, but in each life lived within it. Infinity is vast, but meaning is personal. Still, let imagination drift beyond the stars. Suppose that civilizations do escape the cycle, as we wondered before. Suppose they step outside the wheel, beyond universes, beyond time. What do they find? Perhaps they discover that infinity is not cold and indifferent, but alive with connection. Perhaps every universe is a note, and the multiverse itself is music, a symphony of existence. To step beyond is to hear it whole, to feel the harmony of countless worlds singing together. And maybe, just maybe, that harmony is love. Not love as we know it in fleeting human terms, but love as the binding principle of reality, the drive of matter to connect, of stars to shine, of minds to seek one another. Across all universes, across all infinities, perhaps the deepest truth is not isolation but belonging. Pause and breathe with this thought. The multiverse, with its endless possibilities, may seem vast enough to make us feel small. Yet in another way, it makes us infinite. For if worlds repeat, if universes bloom without end, then every version of you, every dream you've ever had, exists somewhere. You are not limited to this one fragile thread of time. You are woven into the fabric of forever. But even within forever, this moment matters. This breath, this life, this listening. To wonder about the multiverse is not to escape reality, but to embrace it more fully. We are not powerless before infinity. We are part of it. Every choice we make ripples outward. Every kindness, every discovery, every act of imagination becomes part of the larger story. Meaning is not given to us by the stars. We give meaning to the stars by being here to see them. And so we return to the question that began our journey. How many multiverses are there? The answer may be infinite, or one, or none at all. The truth is, we may never know, but perhaps we do not need to. For the value of the question is not in its solution, but in the wonder it awakens. The multiverse invites us not to count, but to dream. Now let yourself rest with this thought. The night is quiet, the stars are steady, and the universe or multiverse holds you gently. You are not lost in infinity. You are embraced by it. Whether there are countless universes or only this one, you belong. You are part of the story, and in that, there is peace. So as our journey comes to an end, let me thank you. Thank you for walking through these mysteries with me, for lending your mind to questions older than time. If you've found even a moment of wonder or comfort here, your quiet presence has already made this voyage worthwhile. And if you feel moved, a gentle touch on subscribe or a small note in the comments is more than a gesture. It is a star that lights the path forward, helping more wandering minds discover these bedtime journeys. I would truly love to hear where you are listening from, and even more, to hear your reflections or suggestions. Your words are like echoes across the cosmos, guiding this work into new horizons. Beyond infinity, beyond the silence, beyond all the unanswered questions, one truth remains. We are here, together, sharing this fleeting moment beneath the same sky. And in that shared wonder, we are infinite.